Still in chapter 24. This is video 5? No, I think it's 6. Yeah, this is video 6. And this is on the metabolic role of the liver. Hepatocytes, liver cells, carry out about 500 metabolic functions. They process nearly every class of nutrient. They play a major role in regulating plasma cholesterol levels, store vitamins and minerals, metabolize alcohol, drugs, hormones, and bilirubin. Here's a summary of metabolic functions of the liver. Now, you don't have to necessarily go through this and memorize this, but this actually kind of ties back everything we've talked about so far into puts it in a nice table form. So it may be worth looking at. It talks about carbohydrate metabolism, fat metabolism, protein metabolism. It goes into vitamin and mineral storage as well as biotransformation functions, which you don't have to go into that into too much detail. So, cholesterol metabolism and regulation of blood cholesterol levels. So first, we'll just start off by saying that cholesterol is not used as an energy source. It is the structural basis of bile salts, steroid hormones, and vitamin D. It's a major component of the plasma membrane, and we only ingest about 15% of blood cholesterol. The rest of it is made in the body primarily by the liver, and it's lost from the body when catabolized or secreted in bile salts that are lost in feces. Cholesterol is transported by lipoproteins, and so that's it. Transport water insoluble cholesterol and triglycerides through the blood, and that's what lipoproteins do. Because remember, cholesterol and triglycerides both are water insoluble, which means they have to have some kind of transport in the blood. They cannot just get dissolved in the blood and then transported throughout the body. They also, lipoproteins regulate lipid entry, exit at target cells. They all contain triglycerides, phospholipids, cholesterol, and protein. The higher the percentage of lipids, the lower the density. And then we have types of transport lipoproteins. We start off with HDLs. And these are high density lipoproteins, and they have the highest protein content. Then we have LDLs, or low density lipoproteins. They have the highest cholesterol content. VLDLs, very low density lipoproteins. Their contents are more than half triglycerides with low density of proteins. And then chylomicrons, they're the biggest, but they have the lowest density, and they consist almost entirely of triglycerides. So we have, starting here, the chylomicron. As soon as I find my cursor, it's always a thing. There we go. Okay, the chylomicron, about 1,000 nanometer diameter, mostly triglyceride, 80 to 95% triglyceride. We have the very low density lipoproteins, 70 nanometer diameter. You can see that's substantially smaller than this, the chylomicron. And these compose mostly of triglyceride. Then we have low density lipoproteins, or LDLs, and these are going to carry cholesterol. Well, we'll talk about that in the next slide. And these consist, they have the highest proportion of cholesterol. And then we have high density lipoproteins, and these have the highest proportion of protein, and they're the smallest. So VLDLs transport triglycerides from the liver to peripheral tissues. LDLs transport cholesterol to peripheral tissues for membrane storage or hormone synthesis. And HDLs transport excess cholesterol from peripheral tissues to the liver to be broken down and secreted into bile. And they also provide cholesterol to steroid-producing organs. We have some recommendations for total cholesterol, HDL, and LDL. The maximum total cholesterol should be less than 200. Above 200 is linked to atherosclerosis, The more important measure is the form in which the cholesterol is transported in the blood. And HDL is thought to protect against heart disease, and this is because it takes cholesterol out of the blood. Above 60 is good, below 40 is not good. And then LDL deposits cholesterol in vessels. 100 or less is good, and above 130 is not good. So now we're going to get into the factors that regulate blood cholesterol levels. The liver produces cholesterol at a basal level regardless of dietary cholesterol intake. So restricting dietary cholesterol does not markedly reduce blood cholesterol levels. We don't consume a high enough percentage of our cholesterol for it to make that much of a difference. The more important effect is the relative amount of saturated and unsaturated fatty acids. So saturated fatty acids actually stimulate the liver synthesis of cholesterol and inhibit its secretion or excretion, from the body. Unsaturated fatty acids enhance excretion of cholesterol into bile salts. So trans fats, this is when healthy fats are chemically transformed into solids like margarine. These have a worse effect on cholesterol levels than saturated fats. They increase LDL and reduce HDL. Unsaturated omega-3 fatty acids that are found in cold water fish have lower proportions of saturated fats and cholesterol, and they're known as the good fats. They help make platelets less sticky and help prevent spontaneous clotting. They have antiarrhythmic effects on the heart, and they can lower blood pressure. Stress and cigarette smoking have been shown to lower HDL levels. Aerobic exercise and estrogen have shown to increase HDL levels and decrease LDL levels. And body shape plays a role. If the person has an apple shape where the fat's carried on the upper body, this is correlated with high cholesterol and LDL levels. And a pear shape where the fat's carried on the hips and thighs is correlated with lower cholesterol and LDL levels. I don't have any questions this particular video, so that's all I have, and you guys have a good day.